All right. Hello, everyone. Welcome to another GDG Cloud Singapore stream. So we have this like monthly kind of webinars where we cover like a whole variety of topics that pertain to Google Cloud Platform, and then you can basically just watch all the various videos that covers all these various topics all on the GDG Cloud YouTube channel. So today we have another topic and another guest speaker. So we have Engin from a senior solutions engineer from Confluent, and he'll be covering on Kafka 101 and microservices. So let me bring him up onto the stream. Hello, Engin.
Hi, Arjun. How are you?
Yes, very good, very good. Yeah, doing okay in this whole situation, but yeah,
We are hanging there. Yeah.
yeah, we're all hanging there. Okay, let me switch over to your screen.
Yep.
Okay, I think we see your screen now.
Okay. Thank you.
Yeah, so now you have the stage.
Okay. Thanks for inviting me, and I hope we will have a fruitful session today. I will talk about Kafka 101 and microservices, and some of the folks maybe they are familiar with the Kafka or the microservices. I hope I try to bring a bridge between these two concepts, and because they're all together. But before starting, maybe I'll talk about my uh, what I'm doing. I'm a senior solution engineer, and previously I was doing the data science related roles and also really technical roles, and I was a researcher previously. And today, I hope I will give you the basics of the Kafka 101. And at the end of the whole presentation, we will have a demo. And in the demo, I will show two microservices, and I will link to the how you can analyze some of your data using the Google BigQuery and also Data Studio. First of all the presentations when we start and when there's a topic, there's always confusion. When I talk about the monoliths, like this is maybe you are in Australia and you saw this monolith before. This is the biggest monolith in the world. But today we will not talk about this. Or when we talk about the microservices, or we are not talking about the I know these days everything is a biology other stuff, but we are not talking about the stromatolites or another micro biomes. Yeah, we are not talking about that. Today, I would like to focus on like the monoliths and the microservices in the tech. And when we talk about the monoliths, actually they have the old way of maybe old fashion of doing the bringing the applications, and which has all the components in big tech stack, and it is difficult to scale. That is a big problem, whatever we see, and also it is difficult to change. And when you know that, when you learn that there's a new technologies, it will take a while to adapt because all the components stick together very firmly. In the new era, we are talking about the microservices and all the applications. Everyone is talking about how we can communicate these microservices well and make sure that like the everything is reliable and resilient. In that case, they start to use the microservices one way or another, and it is good because it is independently deployable. You can easily upgrade these services independent each other. It is scalable and it is good for the agile development. And if you need a new feature, you can develop and plug in to your system. And if you need to leverage new technologies, there's always new technologies. There are new storages or there are new applications that you want to integrate. You are free to do because changing one of the application or updating one of the application will not affect, or it will affect minimally in your tech stack. So today I will introduce you to microservices and how we can utilize it. But before that one, like, if you're a developer, most of the time we like to solve the problems. But if you don't have any problems, how can you solve the problem? Yeah. And in order to understand that, first we need to know how we create our own problems. It always starts with basic things like, oh, I know how to create an app. Like when you're talking with your friends or you have a new ideas, it works pretty well. Afterwards, we say, oh, my application is working well, everyone is using it, I want to do some monitoring and probably I need some database. you add new component. And afterwards, your application is getting popular and you create another application and your business is growing. So you think, oh, now I need a data warehouse because I need to track and I need a like the one source of truth. Yeah. So it sounds good. Like when you're small scale, you don't need to scale up very fast. It looks okay. And then you start to bring new applications. And one day, one of your team member heard about, oh, this is microservices and it is cool. So if you start to integrate everything together, it will try to create problems. And the problem is like when you start to create the problems, you along the way you start to solve the problems, but it is not always expected. Yeah, sometimes the weather change, you don't have any of the knowledge what will happen in the future, it will be a problem. So for this, like the engineers is a good way, like the good point to start, because we are ready to solve the problems, but it is not always clear because people like to confuse the engineers. They always say that I have a lot of data and I want to integrate it. They start to do everything like the getting the SaaS products, microservices, databases, everything is all around. Then one day they say, oh, but some of them is on-prem and some of them on cloud. And expect all the engineers solve this problem smoothly in real time, but sometimes it fails. So as an engineer, you like to solve the problems, yeah? Sometimes it works, sometimes it doesn't work. Like you will never know. So what we do, usually we start, okay, we need to think about that, how we can solve this problem. Because we jump the guns very fast and immediately try to solve, maybe we'll miss some of the conditions. It will be important for the future. And usually, as an engineer, they always talk about the right hand side of the brain and the left hand side of the brain. Like, it is very common discussion. But believe me, engineers has a heart too. Not only the logical thinkers, they have some emotions. What we do usually, we use our like the knowledge, we use our expertise, and start to connect all the components and internalize it and think about how we can solve this problem. And whenever we do this one, it is pretty like natural. Yeah. If you think about the applications, how I want to send this to the database, or if I'm using a software as a service, like how I can integrate that, and how can I do monitoring. All these things in our brain, and somehow we managed to figure that and build really big systems. But what if you have a lot of data and if you want to connect everything together for the communication, why we are not using Kafka? And so far, whatever I see, it will end up always the communication and the integration from A to B. And if we have this problem and we have a solution for that, it is Kafka. And maybe some of us already played with the Kafka, they already use Apache Kafka for other things. But today we will use and I will explain how Kafka architecture works and what type of components we have, because not always we know that all the components and all the required items. So Kafka we are using for the event streaming. And as a developer, as an engineer, usually you are talking about the data stores, like the mainframes or the data warehouse, or you are talking about the logs, or you have the different microservices you want to integrate it, and they want to communicate. When you have the communication, you are using Kafka, and you make sure that like you have a reliable deployment for that purpose. But if you're a business owner, most of the time you don't worry about these things. You have a developer, and they need to fix these things for you. But when I look at this in the really high holistic perspective, if you don't have these applications, if you don't have use cases, it doesn't matter which like the application you are trying to build. And for that one, like if you look at it as a developer, we always reflect to the our use cases. And Kafka will be your like gateway between your data. At the same time, it will enable you to create all these applications and use cases for you. Today, I will talk about architecture, as I said, and we can start with the, okay, it will be a technical talk, I know, but who doesn't want to be in the beach and just relax? Yeah. And Kafka is, I always think that way. The first time I like engage with the Kafka, Apache Kafka, when I start to use it, I learned about the brokers. Like it is really fundamental. And most of the time, if you don't know anyone who knows that, it is like, oh, this is amazing. Oh, it's so silent. I'm doing it pretty well. Everything good. So you only need to know the brokers, yeah. And think this way: if you talk about the brokers or the zookeepers, which is the requirement for that, and think like a beach, and you are resting there, you have data is moving from A to B, everything is smoothly, but sometimes you think that, well, maybe I need to try new things. And all the experiments, not all of them, some of them ends up in a big fire, or you splash some of the databases, you pull all the data which you don't want to do it. Sometimes this happens. So when I feel like that, it is the way I start to use my producer and consumer. Because when I connect to the brokers and if I start to pull the data, oh, I go crazy. I send millions of data in producers in a couple of seconds, and I'm so happy. But like it is not necessary to create a use case to sending billions of data points for randomly. Yeah? In order to do that, like if you have the data, and I start to think about that, how can I make sure that I can process the data and other things? This is another component actually uh, I was thinking about. And instead of creating a producer like and writing all these integration codes in my producer, I realized that there's an easier way to do that, and it's more from like it is if you are in the beach and if you're it's getting late and if you want to have a campfire and eat something, yeah. So for that one, visualize that you have a Kafka streams. And using that Kafka streams, actually you can process the data if you need to do some transformations along the way between the two topics. If you need to join some of the data, it is good. But this again is a bit primitive, yeah. After learning that one, oh, I say maybe it should be easier way and it make my life easier as a developer to make sure that like I can bring my value to my use cases faster. Then suddenly I say, oh, maybe I don't need to write all the the difficult code. Maybe there should be an abstraction for the Kafka streams that I can use. So while I was looking for that, I learned that there's something called KSQL DB. Actually, these are the components, and if you look at the left-hand side, it's a consumer producer, and all the APIs actually Kafka Streams is using to write from them. And KSQL DB also utilizing the Kafka Streams APIs, and but with a high-level SQL-like query. And it is good. Now I realize that I have data in the brokers. I can produce in my microservices and consume. At the same time, I can create some transformations in different ways. But then I realize that I start to share my environment with the other people, and they start to send the data. The problem was the governance, because the data I send, maybe it needs a couple of columns like the username, password, other stuff, and they should be a strict string or the integer. But when they start to send a wrong data type, it starts to fail my consumer. It's a problem. It's same thing as in the nice shore. Now it is getting crowded. Everyone start to use these brokers. So we need to have a governance. In order to achieve that, there's something called Schema Registry. And this is important if you are going for a deployment and production. I believe you don't want to fail your consumers because of the random data created by the producers. So if you think about in a high level and if you want to really integrate your all these different sources, I suggest you to check the schema registry and learn about that. Next thing is, okay, we have the governance, but the problem is I'm not happy. I want to travel a bit. I know these days a bit difficult. How can I go from one point to another point? The easiest way is a bridge. Yeah, like you can have a bridge and you can either walk or like ride a bike or take a car, and you will immediately instead of going to do like walking all the valley and go up and go down. Yeah, it is a like you can do that in Kafka terms. You can write a producer consumer if you want to pull your data from databases or data stores, but we have an easier way to do that. Some of our engineers, like some of the engineers, they already created these connectors, and you can just plug to your brokers and play immediately. You can pull your data from the different data stores, and if you have any problem like integration, getting the data from one store to another, Like I suggest you to check the Kafka Connect. And the last point is, when all the day it's finishing nicely and in nice sunset, and you don't need to write any more Java codes like the Python codes, Node.js codes. So maybe that should be easier way. Maybe I just use a API and produce my data immediately. For that one, actually, there's something called REST proxy. You just need to send your producer or the other like the data, and afterwards everything will be end up in the brokers. Yeah, it is pretty easy. So if I look at in a Kafka architecture and the whole environment, we have different components, and I suggest you check which one is important for your development and use cases, and instead of reinventing the wheel, you can just utilize these connectors or your KSQL lib or schema registry, and you can finish your work immediately. That is easier. You need to work smart, so it will make your life easier. And these are the architecture related components. And today I will talk about mostly focus on the producer, consumer, and how this Kafka works. So when we talk about we have the event streaming, as I mentioned, we have all this technical stack. We have Kafka helping us to connect the dots, but the important thing is our use cases, and we will achieve this one in 3 important cases. First, in the Kafka, we need to know that it has a storage, and it is sometimes you want to store data for 1 week, maybe 1 year, maybe infinite time. You can do that in Kafka. And I will talk about how we store the data. And if you understand the basics of Kafka, it will be easier to develop and utilize the maximum capacity for Kafka. The next thing is it will be publication and subscribe. If you need a message system, you need this information, and I will explain how it works in Kafka. The last part is processing, but today I don't think that I have too much time to explain the processing part, which includes the case stream, Kafka streams plus KSQL. I will skip this one. Maybe in the future we will have a chance to another talk, and I will explain that one. But today I will focus on the storage and the PubSub, and afterwards microservices. So let's start with the storage. And every storage, you need to know some of the abstraction. And if we start with the database, and if I ask where you store your data in database, probably you will answer me table. And if you are using a Hadoop system, it is a file. But when we use the Kafka, actually everything stores in the logs. And today I will talk about the logs. And logs, when we talk about, we know that it is immutable, because if you are changing your logs, which means that it doesn't reflect the reality. And for that, whatever you send the data, what type of data you send to Kafka, it will always at the end of the log. It will always add it to that. And this is pretty obvious. If I send new data, it is at the end. So you know where you are looking for. If you, for example, you want to have a diary and you want to talk about today, I wake up and I brush my teeth, I had a breakfast, all these things when you're writing that one. And it is similar as the Kafka terms, because you write everything in based on the happening and based on the events, and it is logging correctly. Next thing is how we store this data. Okay, data is at the end of the log, but how? Kafka, everything is in bytes. If you compare the other platforms, maybe they are storing data in different way, but in Kafka everything is 0 and 1. If you try to send the data in string, integer, other stuff, it should be serialized to the bytes, and afterwards you need to deserialize in your consumer side. And this is how it works. Brokers, they don't know anything. Everything is 0, 1, and you can send anything. And all this data, you will have a header, timestamp, key, and the value. Okay, and these are the things that you need to know for where you are sending data. Key, it doesn't need to be, it is not a mandatory, but based on your use cases, probably you want to use the key. Later on, I will explain what are the benefits of having the key, and the value is your normal payload. So everything is in zeros and ones. And when I start to come back to the a bit higher level aspect, we have topics. As I said, This concept is similar to database, like in database tables, and we are storing data in like a topic name can be clicks, order, and the customer. And whenever I click something, it will end like it will be in the end of the log. This is how we store the data. But how can we scale? Yeah, that is always a question. And I believe that easier solution most of the time, most effective solution. And I can see in the Kafka that using the same topic, we just need to know the partitions. And partitions have like the topics have multiple partitions. And if you want to scale up, like you can just add one more partition. That's how it works. But there's a one catch here. When you send the data, like if you send the data, it will go to the like the depends on how you are sending the data. In the producer side, I will talk about that. It always at the end of the message and the end of the partition, the data will be ordered like in this way in the partition, not in the topic. There's always a confusion when you start the Kafka and when you start to send the data. Sometimes there are some misunderstanding, and be careful if you need a or strictly ordered data, you should use the key. Later on, I will show an example for that. And as you see, you can scale up using the partitions, and you can, if your partitions can take it like 5 MB per second, adding like the 5 partitions, which means that you can reach to 25 MB per second write or read based on your capacity. Yeah. Next thing is the fundamental. Currently today, I'm giving you the fundamentals. As I said, we have logs, and I adding the first data points like this. The key is the K1 and the value is V1, and I'm keep adding the data. Okay, I have 10 data points or 11 data points, but my use case requires a different approach. Assume that these keys represent a user, and we represent the value represent the address. And in my application, I just want to know the latest location or that user. Like if the K1, the user one, and if I read this one in the index tree, my volume for like the value 4 is my last address. But I don't need to know now these two addresses. Like, how can I achieve this type of like the easy compaction? In that case, Kafka has log compaction is already built in. And if you store the data in a compacted mode, it will always make sure that you have the like the latest information for each key. Like this will be a bit challenging sometimes, but if you understand the concept, like what is log and what is log compaction, for you it will be easier to develop applications. And when you reach the Kafka streams and the KSQL DB, you will see the difference between the K table and the K stream. And I'm giving a preview. Actually, these are the concepts you need to know. And when you have this all this information, you can build on top of this. But the compaction is happening in the key level, and based on the key, you will get the latest information. And if your consumer is reading this one, it will capture that. Okay, these are the storage related information. And if you have any questions, you can just put in a text, and later on I can answer at the end of the presentation. Now I'm moving to the next step. The next step is pops up. Okay, we are talking about the producing data at the end of the log, but the problem is if I want to read, how can I read? Actually, you can start one of the offset that you want to read, and you can always scan towards to the new messages. And this one is pretty easy. But what if I have multiple users for that same topic? Actually, it's not a problem. You can just use the Sally, for example, starting from this and it's reading from that offset. Or you have a Fred starting from another, or the Rick is starting from the another offset. It is pretty common use case actually, using multiple microservices using the same topic for some other processes. And when we start to produce the data, we start to think about, okay, how we produce and how these partition things work. Yeah. And I will start with a no key. If you don't have any key, the data will be sent in a round robin fashion, like partition 1, partition 2, partition 3, and partition 4. It looks smooth, yeah, and there will be no problem. But if I want to make sure that the data is ordered and based on the key parameter which I'm interested in, maybe user events, like if I want to read the data and if I want it efficient, if I store all the users information in one partition, which means that I only interested in reading one partition, I don't need to read like the other three partitions. Yeah, for that one you can use a key, like the in the key and the value pair, you add in your payload is a key metric. And when you add the key and user A data based on the hashing algorithm you are using, it will be getting a module information for the number of partitions. And when you have the A, when you key A, always go to the partition 1, and the B goes to the 2, and the so forth, so forth. And this is how it works. But sometimes we do funny things, like adding a partition. If I add a partition 5 here, what will happen? Actually, you change the formula, and which means that if I have a new A, maybe after this, it will go to the partition 5, which will cause a problem because some of your data is here and some of them will be here. So how can you do this? If you need a really ordered data for particular user, be careful while you are like increasing your partition. You need to make sure that like you are within the boundaries or use cases. And if you really need to increase the partition, it is pretty easy. You can create another topic and you can just like to produce to that topic with the multiple partitions. There are ways of doing it, but maybe it will be a advanced topic we can discuss further. And this is how we produce data when there's a key. Next thing is a consumer. If I have a single consumer and if I have one topic and multiple partition, this poor consumer needs to consume everything one by one, like because no one is helping and this consumer cannot do anything. And this will be your first application. Maybe in the second application, again, there's another application is for different like the use cases, and they can share the same topic and they can read all the data for this topic separately. But what if my use case requires some scale up capacities for the consumers? I need to add new consumers to the consumer. Yeah? How can I manage this? This is a big deal because if I know that this system is reliable and scalable, I want to make sure that like I can consume data faster. How can I coordinate all these consumers? When you create your consumers, you have something called group IDs. And when you attach the group IDs to the multiple consumers, and which means that they are like a member of that group, and they can share the data load based on the partition. And like this will be elected a group coordinator. This happens actually on the backend is automatically. You don't need to do anything manually. And this coordinator check the consumers and then afterwards assign all of them to the particular partition. This is how it works actually. And if we look at our diagram again, like if I want to focus on this consumer one group, and if I have four partitions and if I have four consumers, it is pretty nice match. Like the one partition goes to the consumer two, and they like everyone is having one partition and everyone is happy. The workload is shared. But what if C4 wants to go for a lunch, and probably you need to take some of his work? And this group coordinator actually, when if there's a failure somewhere in the consumer group or like in the machines, it will immediately reassign this partition 4 to the C3 or like maybe C1, depends on the algorithm. But it will happen automatically and you don't need to worry about that. And this is how you can scale up and scale down like your consumers if you see too many lags in your broker side. So assume that you added a partition 5 and you have extra consumers and working pretty well like this way, like this one goes to that. But what if I add like the consumer 6 here? Actually, consumer 6 cannot do anything because there is not enough partition to distribute the data. Yeah. And as you see, the consumers can only scale up depends on the number of partitions and depends on your use case. Again, partitions is important to think about. And you can scale up if you don't need to have any ordering. It will not be a problem. And if in your consumer side, if you're a bit slow and if you want to increase the consumers, adding more consumers not always guarantee that you will get you will reduce the consumer legs. These are the things like it will be important while you are designing your microservices. So when we look at the like really global architecture, we have producers, we have brokers, and we have consumers. In this case, like if you think that I need to add more producers, actually you can just send the data. It is not a problem. It will increase your throughput and everything works well. And if there's no bottleneck, you don't need to touch to the brokers or the consumers. But when you realize that your consumers are a bit behind and they cannot consume fast, maybe you can add one more consumer into your consumer group and it will start to consume faster. And which means that there will be no bottleneck and you can scale up based on your producer side, consumer side, or if you need the extra brokers to boost up your like throughput, it's also possible. And it will help us to linearly scalable architecture. And this is how it works. But in order to scale this way, probably you know that we are replicating data from places to make sure that we have a fault tolerance. How it works? In the broker side, we have the multiple machines, and in these machines, there's a leader and the follower. Yeah, and this leader is in charge of the writing and the reading data, and there are consumers like the followers needs to replicate the data from this leader, and this is how we achieve the fault tolerance actually, because when you have these machines and like if something goes bad later on, I will check that on how it works, and it will be helpful to retrieve the data immediately from your brokers. First, before that one, we need to understand how the leadership and replication works. In this example, we have three replication vector, yeah? And I have a topic X and I have partition for partition. I will distribute all these partitions across all available brokers. In my first partition, it will go to the broker one, and as you see, this orange ones are the leader, which means that consumers and the producer are interacting with this one. And if producers are writing this partition one, it will be replicated to the partition one in the broker two and the broker three. And we have the different acknowledgements, like the either you will have the without acknowledgement, you just send the data and forget it. If it fails, you don't need to worry about that. And maybe this is your use case. And maybe you just need to get the acknowledgement if you're a producer here, and you only get the acknowledgement for the broker, like the leader. It is acknowledgement one, or you can make sure that your data is replicated to the across all these brokers for partition one. For that one, you need the acknowledgement all. These are the important metrics, important configurations when you are designing your system. And make sure that like depends on your use case. If you don't want to lose any data and if you want to have a unique data points, like the acknowledgement all and the idempotent enable true will be helpful for your producer side. These are the configuration you are looking for. And other things are like okay, we send the data, we replicate the data. Partition 2 is in the broker 3, broker 2, and partition 3 in broker 3. So we set up the all my brokers, every machine is running, but every system fails. Like we cannot do anything. It is meant to fail. So how can we provide the resiliency if there is a machine failure? In that case, if you look at the Kafka terms, like we have the 4 brokers and broker 4 is done. The only affected topic for the writer and the reader side is the partition 4, because these are the leader. This one is the leader, like the broker for the partition 4, and our group coordinator, like our broker coordinator, immediately switch this one to the broker 2, and your producer and the consumers will read this one, all the data in the broker 2 since the broker 4 is done. It will be automatically balanced and you don't need to worry about that. It is already built-in feature. So if you look at the system in a different aspects, we have the resiliency and the high availability built in, and that's why we are using the Kafka. that brings me the question: why log like that? Okay, it looks like a durable messaging system because I make sure that my data is not lost and I can send the unique data based on some different configuration in the producer side and the broker side. And in the traditional messaging system, like if you are familiar with them, it looks okay. It can be possible for them, but the differences are pretty straightforward. Scalability, like you can scale, you can add many brokers, and you can scale up and scale down at the same time. Built-in fault tolerance and high availability. You don't need to like to deploy another extra brokers to make sure that like in another region everything is coordinated and working together, so it is highly available. And the key aspect is it has a storage, which means that you can replay the data. It is not like oh, I send message and I read it, I forgot it. But 2 days later, maybe you want to know that what did you do uh, 2 days ago. You can go back and read the data again. So it's not a problem. So these are the basics for the Kafka, the storage side, and the PubSub side, like the producer and the consumer side. As I said, like there's another important aspect, like the processing the data, but I don't want to go that direction today. I'm immediately switching to microservices because if we have the microservices, if we know how to use the Kafka and how we can utilize it, we can immediately start to deploy or the like the from monoliths we can move to the microservices architecture. I will start with a really basic and a common architecture. Usually what I see is we always have the UI, we have web server, and this web server interacts with the payment servers and the order servers and sometimes in the customer service, depends. And internally, this order service depends on the fulfillment service. Maybe it needs to check the stock before, like the uh, check, like the giving the orders to the customer, and all are like it's intermingled, and we need to make sure that everything is running. And if one of them is done, which means that there will be a cascading event afterwards. Yeah, so it will be a problem sometimes. So we need to be careful while we are designing our own architecture. Usually, like if you want to like many services, you need to know some of the core facts of your services. What are the domains of that services? And is there any overlapping data that you want to share with the other services? And how can we make it pretty easily achievable with the Kafka? That is the actually whole idea. And how can we change this monolithic architecture to microservices? Yeah. And if you have microservices, the first thing is you have two types of events. One of them is a notification, and if you want to make sure that like the order is fulfilled and all the stuff, and some of the uh, consumers are listening them and sending some notification to the customer. Or maybe you want to replicate some of the data between the microservices to make sure that data is well used and they are sharing the data in the same domain or in the overlapping domain for the different services. It will be a backbone, like all the data goes there and everyone knows that this will be a single source of truth. And if you look at the notification data replication, first, like we always start with the natural way, yeah. And if we think that the RPC is pretty straightforward and easy to use, we submit the order, and we call the service, and we expect that the service will reply us true or false or other things. But sometimes this RPC starts to drop, and what will happen? You need to ask again, and if it isn't reachable, you need to ask again. So sometimes it will create a friction. And if you have many systems and if one of them fails, it will start to have a cascading event. And you always go back and check the logs. And if you are checking logs for your problems, why in the beginning didn't use a log to make sure that everything is working smoothly? That's always the question. And if I have this order service, and how can I make it more resilient here? The first thing is like I want to make sure that I know all the services, and this one doesn't look like we have a Kafka. How can I like separate all these responsibilities. I will start with the order service. And if I have an order and if I want to make sure that shipping service is in touch with the customer and sending all the goods to my customer, I don't need to keep asking, okay, did you send? Did you send? Yeah. Like if you have a colleague and if you are like doing some coding, probably if you click, oh, did you finish the function? Did you finish the function? If someone keeps repeating this, it will be difficult to develop the stuff. So in that case, what will you do is you just say, I created the order. This is my job. I created order. And it is your job to read that order and ship it. That's it. And then what will happen is fire and forget. And it will just remove all this friction between two services, and they will work even though maybe shipping service the team is for a lunch break, and you know that maybe sometimes you have a longer lunch, and when they are back it will not be a problem. They will continue where they left and they can continue shipping their goods to the customer. So and we remove the first RPC calls for that. And the next thing is we want to make sure that how can we scale for the other services, yeah. And maybe in the shipping service you need to have some information from the customer service and they want to share some data. And in the web server side I can update my address and all this information after I order my goods. Maybe I change my mind, I want to send my work but something happened, I want to send this all the goods to my home. So in the customer service database maybe you updated your address, it should somehow reflect immediately to your shipping service. But if you keep asking in shipping service, maybe you will miss the updates. And what will happen is, if there's a new update, customer updated, it will be synced towards using Kafka with the connectors into the internal shipping service user database. And the user database doesn't need to know all this information, maybe only required address information, and you don't need to like the share social security number with the shipping service, and it will help you to mask some of the data that you don't want to share with the different domains, and it will be helpful for the security too. So what we did here is customer service call is gone, and now like the data is replicated when there's a new event in the customer service. And now if this database is down, this will still work and there will no problem, and this will help you for the resiliency. And like this keeps going and going and going. I will talk about these microservices for different aspects, and we can drill down the payment services like in orders services, but probably it will be too much for that talk because we start the basics today. And you will learn all the other things actually pretty easily in different talks, and we already have, and I want to keep it short and brief. We have a developer team, like we have a community, and if this is the Singapore group, and if you are in Singapore, please free to join. And if you are in the other part of the world, we have the different user groups for every city, and I suggest you to ask any questions, and you can use this slide, maybe you can use the QR code for the developer related questions. And afterwards, after the community advertisement, I will go to my demo, and I want to explain like why we are using microservices, and I have some services I want to introduce. Then afterwards I will show how it works in my architecture. Today I'm not sure how many people like to read books, and if they are still ordering the books in the physical way or they are reading from online. I don't know that, but there's always an interesting question to manage the orders. And my today I want to focus on the bookshop. And usually what we do is we create the orders and we sync the orders in the transaction database. There will be order details, and we start to build things like the slowly. As I said, while we are building, sometimes we create problems too. And okay, someone ordered books, so what we need to do, we need to ship these books, and that another module in my architecture probably needs to shipping details, and it is pulling the data from database. Okay, it looks good, but the problem is like I want to monitor what's going on there. Maybe I want to sync all the data my data warehouse, and okay, it is doable. and I want to monitor and I want to make sure that my all books are arrived on time. And maybe I want to do some improvements like the analytics regarding to shipping estimation time, if I'm estimating correctly, if there's a problem in my logistics, or maybe or not. All these things I need to bring this management into my shop. But if you look at this way, actually we built a monolithic architecture again. Yeah, like we have a really limited touch point, and probably in the one server I can create one database, and I can ship everything and visualize all the results. It doesn't solve our problem actually. Again, this will not be scalable. If suddenly I have a big bookshop in online store and I fail to achieve like the reliability in my system. So how can we convert this one a microservice architecture? Today, like the I will have a Kafka brokers and zookeepers, everything is deployed, and I will have a schema registry. And for that one, I'm using a like the fully managed Confluent Cloud for the Kafka deployment. And but the problem is, how can I navigate all these things and how I create all my solution? My case, I like to use Python. Like I develop a lot of stuff in Python. I'm very familiar with that, and I want to integrate my producer and the consumer, also my admin client, using the Python. And it's already available, like in Kafka environment. Like we have like many different libraries available for different languages. Like if you're a Java developer, Node.js developer, Kotlin developer, they're all available. You just need to create your producer with the library and send the data. So in every production, I always suggest to segregate all these roles. Like if I'm an administrator, I need to have rights to create topics and the register schemas. But I shouldn't send data to brokers, yeah, because it is the producer's job. That's why if you segregate that one, what will happen? Producer doesn't need to create topics and doesn't need to check that if there's a topic in the brokers. And also, if the producer doesn't have a like the privilege to create schemas, which means that it will not register wrong data immediately. It will be rejected. So for that one, first I build my admin client, and which has a privilege to create topics and the register schemas. That's it. I have two topics today. One of them is the order details. The second one is the shipping details. In my order details, I have a producer. It is a book order microservices, and I want to produce data. But if you want to use a schema registry, the smart way to utilize the schema registry, actually you can cache the schema in your producer local cache, and you don't need to keep asking the schema registry if this schema is correct to send the data to brokers. This is pretty important because otherwise there will be a slowness because you need to ask the schema registry multiple times. In these clients, there's always availability for the cache schema registry, and just check that one when you are building a system. Next thing is I pulled my schema registry. If I have a JSON payload or like the Aurora, I want to serialize the data. And these microservices, when they produce the data, it will serialize based on the schema I have. And if it complies perfectly, it will send the data to brokers. In that broker, I will have a order details information. Okay, this one is done. Now my shipping consumer, same idea. I create a consumer which can cache the data, schema registry, and then pull the data consumer from like the brokers and deserialize the data. When it deserializes the data, it knows that now, oh, okay, we have the string, we have the integer, then I can do some calculation of the stuff. Or maybe I want to do some like the additional data, like the estimated shipping time for that particular address. Actually, this is pretty important because if you know when your shipping will be there, your customer satisfaction will be better. So this shipping books consumer will consume the data, but afterwards, after processing some of the data and making sure that the books are ready, it will produce back to the brokers to the another topic like the shipping books topic. And in that case, what will happen? They are all interacting each other, and everything is fired and forget. Okay, we solved the problem. Data is flowing, consuming, shipping details are ready. But what is next? If I want to do an analytics, the first thing is, as I said, we have the different components. Think smart. If you need to sync the data, send the data to another component and another storage, there's easier way to do that. It's Kafka Connect. I don't need to build or reinvent the wheel to send the data to my data store. This Kafka Connect immediately retrieve the schema and consume the data. And from the, you can pick any of the topics, like multiple topics is also available. And today I want to sync the data BigQuery because I wanted to do some analysis. I want to see my addresses. I check the addresses and see that where my books are traveling, like to which countries or which continents. Okay, I'll sync the data in BigQuery. And the good part for the connectors, like if I change the schema, it will immediately reflect to my BigQuery, and I don't need to like go and fix the BigQuery schemas or other stuff. Everything will be operated in Kafka Connect, and this will help you to for the producer side and the consumer side, like if you're syncing or getting the data from the databases or data stores. And then afterwards, that is pretty easy. You can just visualize your data in Data Studio and see how things work. Today, I will walk through all these steps. Like I will send the data, we will see data is flowing. We will check that one, and then afterwards, I would like to answer your questions. And for the presentation part, I know it was a long presentation, and this will be the last. Like if in the future, if you have a chance, if you start to implement your microservices using the Kafka, and more or less you start to build these different services like the fraud service, reading the data from the orders, checking that one if it is the payment is correct or if there's something some issues, and the order service will check to validate the orders. You will have an inventory service needs to check that if you have a correct inventory for that one, and afterwards you will be synced to the all the data to order validation topic. Maybe this will be new topic, then afterwards you continue and the process data. This will be high level microservices for the order service, and this is your challenge. I believe you can build this one uh, like after learning Kafka and starting to use it. So let's go to the demo. And in demo, like it is pretty easy. I will give you the basics first. I will give you a terminal. Like I know some of us really like the terminals. And what I do is the first thing is, where is the data? Like we always discuss about the data. I will bring my broker side, and my data will be in this Confluent Cloud clusters. And the Kafka clusters broker are all deployed here. And I already have some topics. Like I already created. I don't want to wait to do the admin work. I create my order details, and also I create my connector. Like if you look at the order details are ready, and the schema already ready for us. And these are all registered with the just one admin Python code. It is pretty straightforward. And the good part is, like if I look at my integration, I have a BigQuery sync connector today, and currently I didn't process anything. Later on we will process together, and this will be immediately sync my data to my bookshop. And as you see, I don't have any tables yet, and let's see how it goes. Okay, let me first of all, like I have the ship books. This is my consumer, and I just want to activate my consumer, and at the same time it's the producer for my shipping books. And today maybe I will send 10,000 orders, and it will start to connect to my Confluent Cloud, and it's already sent the 10,000 and more than that, because previously I sent a couple of thousand messages, and it is sending data actually here. Like you can see that it is processing my shipping details and producing back to the shipping details. It is pretty straightforward. And if I go to my Confluent Cloud site, I can check my order. Like if the data, maybe I can check my last data points, and everything is in Avro format, and I have a key, and this is pretty straightforward. And if I go to my schema, my topics in the shipping details, like I'm currently producing some stuff, and like it is producing all the data. And as I said, if I want to send more data, like another 10,000 messages, 10,000 orders, I'm producing it. And as you see, this consumer a bit slow. As I said, I can spin another consumer to make sure that like it will catch up if I have a more partition. This is already available, but it is for you to try. It is pretty straightforward. And afterwards, what will I do? I just need to go to my Google BigQuery site, and I just need to check what is going on there. Let me check my tables, and I will talk about the bookshop. And in the bookshop side, I will get the data after the data will be synced to the in the BigQuery side. Like, let's do that one. Okay, let's start the connector again. Then it will be yep. I think okay. Let me see. Maybe it's always the demo case. Yeah. I need to say next and launch my connector. Oh, okay. I need to. Okay. My credentials expire. I think I built this one. Yeah, I waited a bit long in the Confluent side. I need to join again. This timeout is happening because of the security controls. And if you talk too much, and you cannot get the data flowing. Let's go to the settings. Okay. Okay, I think I'm still sending the data. Yeah, it is still sending the data. Maybe I can show the lineage first, then we will see that like how the data is flowing. And then afterwards we can check the BigQuery site. But at the same time, if you have any questions, you can just ask in the chat, and later on I will answer all these things. Okay, yeah, this is the BigQuery site. And what I did is today, like I had the producer sending data to the shipping details, and I need to check my connector. I think, yep. And then afterwards, like when I start to send the data, what will happen is I can go to BigQuery and then send data. I think I just need to renew my credentials because I forgot to update my credentials. That is why it is complaining. Okay. Let me go and check. Yep. I think I need to re-upload my credentials, but let's last try if I couldn't upload. Okay, now connector is updated. Yeah, I think I need to check my credentials. Yep. Any questions? I will fix this one while waiting for the. I will update my credentials now. Sorry about that. I'm not sharing that one because I need my credentials file.
Okay, Engin. Maybe
Yep.
I'll present the questions to you, then you can answer it while you attempt to debug your demo.
Yep.
Okay, let's go one question at a time. Let's go with the first question that came up 20 minutes ago. So the
hmm
question was, does Kafka support automatic data rebalancing?
Yep. It will support like the depends on the service you are talking like when you are talking about the broker side or the like the consumer side. If it's in the brokers, like the data will be distributed based on your partitions, and the afterwards, if you need the consumers, and they will be balanced based on the like the consumer groups. So there's two different things, and maybe if we have a extra information for that, I can explain more for that.
Yeah, so if the person want to provide more context,
Yeah.
more details regarding his question, then Engin can like reply more and give more details. Okay. So while we are waiting for that, let's go to another question, which
hmm
is kind of half answered a bit in the chat, but let's also just cover it for full coverage, which
hmm
is regarding like whether Kafka can be utilized along with Golang. So it's more like whether there's some sort of SDK or integration, I guess.
Yep, there's a Golang. Actually, this one is pretty like the like if you go to the Golang library, I can share with you. Like there's a Golang client, and you can just utilize. And there's always examples. Like if they want to utilize the Golang, yeah, it's available.
Okay.
Yep.
So hopefully that answers the person that was asking.
hmm
Yeah. So a search can, this is the official SDK, right? That is like the Confluent kind of
Yes,
produce.
this is a Confluent official SDK. Yeah.
Yeah. So yeah, the support is kind of there, so we can like essentially use it with less worries, like like the library
Yes.
being deprecated or something.
Oh yeah,
Yeah.
yeah, yeah, definitely. Like if the because Kafka environment, like the currently it's in the version 3, and if you are using like the older versions, like the two, probably along the way there are too many upgrades and also too many improvements. And I always suggest to use the latest version of the clients to make sure that like you have a patch and the environment. Yeah.
Okay. Okay. That's good. That's good. Another question that someone was asking is whether this I'm not sure what feature exactly the person was asking. The person was asking about something about Azure Cloud. But yeah, I mean,
hmm
although this is the GTG
yeah.
event, but okay, let's just answer for to cover our bases. So I'm not sure what part he's trying to ask about. Like, is it the whether the Kafka, like the site that you're showing the Confluence, whether it has the integration to Azure. I think that's what he's asking here.
Oh, okay. Like the Confluent Cloud is agnostic to the all clouds, so it has integration. Yes, I
Yeah.
can answer this way.
Yeah. So hopefully that answers the person question. This pretty shading. Hopefully I pronounced his name right. But yeah. So hopefully that answers your question.
yeah.
Let's convert that. So um so Engin, do you is the debugging going fine, or you want to just
No, I
go
just need to
straight?
up. Yeah, I just need to update my credentials, but I don't want to share my credentials, so that's another thing. Yeah. Okay, maybe I'll. Okay. Any other questions for that one?
Right now, so far no questions have been coming up on chat. But I got questions of my own as well, if you don't
Yeah.
mind
Yep.
answering that. So just now, you were mentioning um about the number of partitions and number of consumers. Like
hmm
you mentioned a point where you can't exactly there's no guarantee where just adding more consumers will make the consumption of the messages from the partitions go faster. Like there is like
Yes.
let's say if you have five partitions, then kind of the max is uh five consumers. Yeah, correct me if I'm wrong there.
Yeah, like if you have partitions and if you have six consumers, it will not work because the coordinator will assign each consumer to one partition. This is how it scales up.
Okay, so I got a question here. So regarding
Yeah.
that, so let's say if the consumer is like really, really slow, like maybe it takes like half an hour to process one message, and then your
Oh,
producer just like producing message that is crazy. So how do you deal with this scenario? Like, do you, yeah, not exactly
okay.
too sure.
Yeah, like because I saw many deployments and I saw that like there's a blocking events. Like if you're a consumer and if you're blocking like all the processes with the one big processing, for example, if you have an event and if you got the event and for that event maybe you are trying to book a air travel, yeah, and you need to go all the websites to check all the prices, but this sometimes take too much time, and maybe 1 second or 2 seconds, like my too much time is more than 1 second, and which means that you need to wait 1 second minimum to make sure that you can consume the other consumers or other messages. If you can do it in an asynchronous way, like the consumers have a synchronous and asynchronous way. If you need to have a proper order and if you are doing a synchronous way, so you need to wait that one. In that case, I suggest to segregate the responsibilities, and like what I do usually if I'm a Python developer, and I use a parallel processing, like I spawn multiple threads and send this data to the multiple threads and collect their information asynchronously. But again, this will be a use case dependent, and but I can suggest that don't do a blocking processing in front of the consumer, like after the consumer, because you will stop the whole production afterwards. Yeah,
Okay, so some slight changes need to be done on the consumer end.
architecture. Yeah,
Okay,
architecture. Yeah,
okay. Yeah, that will be one thing to take note of.
yeah.
Okay.
And
Um.
maybe
Oh,
I can just spin like put my credentials here. So maybe I can show how actually I connect them this one. I just picked this order details and shipping details, and my data is in Auro. And let's make it second. And these are my API keys and script which I need to use to send the data. And auto create tables you can do true. And then afterwards, like the auto update schemas, you can true, which means that if I change the schemas, it will be helpful. And all these are available. I just do a really basic one, and no partitioning, and there's only one task. And if I copy the things correctly, and it will it will take a couple of seconds to run because it needs to provision. Afterwards, I will have the data in my BigQuery. Yeah, this is actually what I want to do. I prepared this one before, but probably while I was rushing, I put the wrong details there. Okay, so any question?
okay. Are you going to show the BigQuery part? Oh,
Yeah,
yeah.
yeah, that's why like that. I think I copied the wrong API key. So probably today I couldn't show that one, but at least we have the data flowing in the producer and consumer side. Yeah, yeah. This API key is always a problem. Yeah, you need to copy correct ones, and if you have
Yeah.
too many,
I
yeah,
mean, there are, like some demos just do that once in a while. The actual thing.
yeah,
Um.
yep. That's
I
all from my side.
Okay.
Yep,
So in the meantime, if so far there's no other question that came up, but okay, like in the maybe you can entertain with me with just one more question from me,
yep,
while we wait for any other questions to stream in.
yep,
So I was just wondering just now when you were showing the part about there was some portion about the schema registry, I think, like
yep.
producers or some admin need to register the schema, right, for the applications that are going to be connected to Kafka. So let's say if there is a schema change,
Mm-hmm.
um, do, do you need to like kind of update all the producers and consumers
Not
to use, or like how do you do a smooth
oh,
upgrade?
oh, it's a pretty good question. Like the actually that brings us a different topic. There's a compatibility mode, like the backward compatibility, forward compatibility, full compatibility. And sometimes, like when you have the applications, you need to change a breaking. You need to do a breaking change, yeah, in the admin side. That's why I told you that don't change in the producers. Like the producer has a privilege to send the schema. So if I upgrade my schema, like the backward compatibility, which means that like it is updating, the producer still continue to produce the data, it will not be a problem. And maybe, okay, that will be actually bring me a really good uh, point. I can just share that with you. And it's a pretty common question actually, like I saw in the field, and people wants to learn about how the schema works. And for that one, I can just share the schema registry and the logistics. Let me jump to that immediately. So, like as I said, when we talk about the schema registry, and if you know the basics, you can immediately understand how it works. Like the first, without a schema, like what you say, you can send the big data to producers, and the broker will go there, and the consumer will go there. And but what if you have this type of data and you are changing the schema, you are adding extra information, and the producer send this type of data, consumer will fail. Like you will break your thing. And if you add a schema registry, what will happen is like you have the schema and it will register the schema registry. In our case, I suggest to use the admin for the like the production cases, because if the producer keep registering the new schema, it will be not feasible. So it can break the if you give all the power to produce, it can break the registry. So it can get the schema ID for IDs, like 4 bytes only, and it will serialize the data. As I said, broker only knows zeros and ones, and the schema ID works here, and the data is in 0 and 1s, and if it goes to the consumer side, and again we have a local cache, it will to make things faster. If there's not in the local cache this schema ID, it will retrieve from the schema registry, then it will deserialize and assume that you change your schema, add the new columns, like the maybe favorite color, like the something else. Producer, if they have the schema, they can produce, and in consumer side they can upgrade and they can get the new schema ID and they can use it actually when you upgrade your consumer. But there should be a logic, yeah, there should be governance. It brings your question, like the backward compatibility. And if I have my schema is the first one, is the version 1, I have only 2 items, name and favorite number. And if I go to the upgrade my system, my application is really popular, and I want to capture the favorite color in my application. And if you add a default value as a green in a version 2 in your schema, what will happen? New schema can be used to read the old data, which means that if I upgrade my consumer to version 2, consumer version 2, and producer to version 1 still, this data can be read by the consumer version 2. It's pretty easy, yeah. And this is how it works actually, like which one you can upgrade or which if it fails or not. And if your upgrade is working, because Avro will use default value, if you don't send me the green, I assign as a green. This is the logic of the consumer. And there's a forward compatibility. Actually, it is the vice versa. I'm adding the favorite color without the default, which it means that old schema can be used to read new data. Like the consumer is still in the version 1 and the producer in the version 2. Okay, this consumer is version 1, producer is version 2, like this is version 2. So if I produce data, this consumer still can read it, just discard this favorite color. And this is how it works. Like if you're upgrading your system in the consumer and the producer side, like this admin will upgrade the schema probably in your production. And you need to make sure that which one you need to upgrade first. and otherwise you will break the system. But the best part is if you fully compatible, and it doesn't matter actually, it will not break any system. Like usually if you have a default value, the backward compatible actually at the same time it was full compatibility. And if you achieve in your schema this type of things, and you don't need to worry about producer or consumer, it will not break the system. And this will be achievable if you add and remove the fields using the default values. Okay, and this is how it works. But again, we are a developer, and when we are a developer, we like to break the system. Yeah, I can give you the how you can break the system in that case. If you rename the required field without the default, like if you name and make it a username, and you break the system, congrats, no producer and consumer start to fail. And changing type of the field, like because if you want to serialize the data, if you are looking for integer, or if you're a consumer, if you want to consume the age of the person, and suddenly there's a string there, it will fail. Yeah, so it will break the system. And if you are using a enum type, enum is like a true false, like there's an array and your field expecting, like if you are using a protobuf in Google and all these things. And what will happen is you will fail if you change true false maybe, because your consumer or producer is not expecting maybe that. And these are the way you can break the system. I hope it is clear. It was a bit long answer, but this is how you make the system more reliable or more dangerous.
Yeah, I get your point.
Yeah.
Yeah. So I mean, this is kind of like because I think a friend of mine was mentioning about this message queuing system, but I think he was doing it for a data team or something, and then he came across this same problem, and he was like scratching his head about it. So
Hmm.
yeah, maybe I'll share this information with him.
Yeah, yeah.
Yeah.
This one is pretty, like if they are using protobuf, actually Auro is comply with protobuf. Uh, Kafka comply with the protobuf, and you can use the protobuf serializer or deserializer. And I know in the Google environment is very common using the protobuf, and maybe they can look for that, like the how can they integrate all these things with the schema registry.
Yes. Yes.
Yeah.
Okay. Looks like there's no further questions that's coming up in chat, and I
Okay.
have no questions from my end. So
Oh,
I guess yeah. I mean, do you have anything else that you want to share once more? Maybe you want to share the Confluence community page once more, just in case
yeah.
anybody wants to take a look.
Yeah, I think like this is the community page, CNFL.io community. Maybe I can make the full screen. And like if you want to check in the developer page, actually it is pretty nice. And if you want to kickstart to use Kafka, you can start to download the basic codes from developer web page, and then you can start to build your application. And there are really nice tutorials and also really nice lectures, and they can maybe I will last one time I will just log into that, like go to that one. Run, yep. This is pretty convenient. Like if you want to learn any courses, Apache Kafka, connector, streams, KSQL DB, and these are like the 2 minutes, 5 minutes YouTube videos, and you can just watch and understand how things works. And in this Apache Kafka 101 series, and when you learn this, maybe you want to build some stuff, and with the favorite language you want to use, actually it is pretty Java, Python. You can pick any of them, and it will give you like what you want to do and what you need to install. All these things are pre-built, and you can just prerequisites like you can create a project. These are the scripts you need to do for Python. All these things. Is I hope it will be easier to understand how Kafka works, and I suggest everyone to check all this for the newcomers and if they want to learn how these things works. And there are some use cases too. Yep.
All right, that's good.
Yeah.
Oh yeah, Engin, if you don't mind, I think one question kind of came up last minute.
Yep.
So
Yep.
maybe you can answer that, and then we'll finally stop the questions here.
Yeah.
So because I think it's the question that came up is kind of interesting as well, which is hold on, let me put it up. Is it possible to secure messages between different microservices? Like only certain services can read certain topics.
Yep. Like in the Kafka deployments, they have you can define an ACL. Like in Confluent side, it is pretty easy. You need to create an API key, and API key has a granular access. Like that particular API key can only access the one topic, like the only for read. Maybe I can quickly show that one. And the problem is again the API keys. If you don't do it properly, like sometimes you will have problems. And the API keys again, I have two API keys like I created, and I need to revise them. And you can have a granular access, and you can create a service account for that. And then when you go to topic in the like you can select one orders topic and only give them a read access, and you say off, and that's it. And in that ways, using this API key, you can only read this topic. That's it. You cannot do anything else. And you can have the granular access to that information. Yeah. I hope it will be if you are like the if you want to check for the security, I suggest you check Kafka ACLs and the wildcards. It's already there.
Okay, hopefully
Yep.
that answers the question that was raised in chat. I guess with that, okay, thank you, Engine. Thank you for your session today.
Yep. Thanks a
I
lot.
mean, it like I've been interested in Kafka for quite a while. It's just that every time I want to approach it, it's just like, oh, this is quite a big system to think of, and especially like already the starting point, just like, oh, you need zookeeper. It's like, what the hell is zookeeper? I just come here for Kafka.
Wow, that is yeah, that is the most of the time concern I see like the zookeeper. But after Kafka 3.0, like we start to remove with the K-Raft, there's a new algorithm which take over the zookeeper's responsibilities. And if you're really interested in Kafka and how things works, there you need to check the K-Raft algorithm. And like if you're a developer and if you're a bit techie, you will enjoy to read some blogs, and probably it will help you to adopt faster instead of you trying to figure out the zookeeper or the brokers.
Yes, yes.
Yeah. Good luck for you. And
Yeah,
I'm happy
probably.
to have another session. Like as I said, we have too many topics. As I said, we have too many components. But maybe in the future we can arrange another one with a specific topic that you are interested and want to try.
Yes, yes. Yeah, let's do
Oh,
that. Maybe we can have a poll with the community to see like what topic they want specifically with Kafka.
yeah,
Yes, let's do that.
sounds good.
Okay. So once again, thank you, Engine, for your sharing. So hopefully this session today is informative for everyone on stream.
Hmm.
Hopefully we can invite Engin once more so they can cover like specific topics, or if anybody has like specific questions or topics that they want to be covered or they want to ask about, just leave it in the comment section. Then maybe I can like arrange another session with Engin to like um, have a like full webinar regarding that topic. Yeah.
Yep. Thanks a lot. Thank
Okay.
you having me for today.
Thank
It was a
you.
pleasure. Yep.
Okay. I'll put you to the backstage.
Yep. Thank you.
And I'll need to cover the sharing. Okay.
Okay.
See
Thank
ya,
you.
Engin.
See you.
Bye.
Bye.
All right. So with that, we're gonna end our session today. It's been a long session. It's almost like an hour, 30 minutes. So with that, as per our usual, I mean, Engin is one of our guest speakers this time round, but we are always on a constant lookout for speakers, especially with this kind of deep technology integrations and everything. Like, it's kind of hard to find people who have in-depth knowledge in this and wants to speak about it. So if any of you um, have some sort of like expertise in this and want to speak about it, do reach out via this the URL that's on screen right now, and then we can arrange something. Probably maybe this time any sessions that will be arranged will be probably for next year. I mean, December is coming, so I guess like people are gonna go for holidays and everything. So next year will be a fresh start, and yeah, new sessions can be arranged for next year. And with that, if you liked the content that was shared today, if you like, all these technical topics, maybe something that's slightly out of the Google ecosystem, but then kind of integrated with the Google ecosystem. If you like these kind of topics, do leave a like, subscribe to the channel if you want to have to see more of such videos. We do share all this what kind of webinars and everything. We do share all this like what's happening on Facebook, on Meetup and these GDG sites as well. So if you want to like keep in touch and find out like what kind of topics or webinars are going to hold, you can go to those social media websites and just just wait for those announcements to come up. Or if you want to communicate with other people, other like-minded people in the GGG Cloud Singapore community, you can go to Slack. Right now, it should be quite active because we are still holding the Modular GCP Season 4. In case anybody on stream didn't know, Modular GCP Season 4 is still kind of running. So if you are in it, do try to complete some of the quests so that you can hit the minimum bar to like get all the swags that's on the site. Yeah. So with that, thank you for attending the session. See you next time, which is I think tomorrow. Tomorrow there's another webinar. So yeah, bye.